Hi there, we're here at SY Systems. My name's Rob Thompson. I'm the sales manager for SY Systems, and I'm with Matt Jones here.
Hello.
From Stratasys. He's a senior application engineer. And today we're going to talk a bit more about the Origin 1 product, which is a P3 technology. So Matt, take us away. There's a bit more.
So P3, basically it's a DLP based system, so digital light projection, and it's a bottom-up approach. So underneath we have the projector, which shines a light through into a tray with the resin that's in there, and then you see the build head or the arm there that sits in the resin, and it builds upside down and comes out of the resin.
Sure.
And brings it
I'll
out
get
that
the
way.
door open for you so you can see inside.
So inside, what's interesting about this DLP system is that it's fully enclosed and it's temperature controlled as well on the inside. So we've got a series of sensors that monitor temperature, separation forces, the exothermic reaction of the material itself inside. You have the tray that you fit the material in, holds around 2 kilos of material, so you don't have to worry about printing stuff overnight and having to top up. There's more than enough on the inside. Locked down via magnets. I'm afraid the lights only come with red. You can't have disco lights going on the inside. You can see here the guys at SYS printed a dental arch before I came in. So it's about an hour, obviously, for one. But as I mentioned on one of the other videos, it doesn't matter how many parts you put on the tray or on the build platform, because it's DLP, it takes a black and white image. So as many as you have on, it takes the exact amount of time to cure the same layer.
Right,
so if you were to fill that and nest them all in, maybe you'll get sort of, I don't know, 6, 7, 8 arches on there in one go. It'll print at exactly the same time. It's just the Z height that determines the print time.
Right.
So this was 100 microns and just shy of 50 minutes to print.
And the variation in time can come down to the layer thickness, but also the viscosity of the material that you're utilising as well.
Yeah, quite right. So depending on the viscosity, the centre poise of the material depends on separation time. So how far we move the platform up, how long we allow it to wait. So the thicker, more viscous the materials, the longer the build time will be. Obviously you can do 100 microns, 50 microns. The thicker the slice height, the quicker it'll print off the machine. But things like this, you know, it's a pretty viscous material, free flowing, shall I say. Other materials will print much quicker, maybe like a couple of seconds to print a layer.
Wow.
Others longer, especially for the elastomeric filled materials, much thicker. Even the 3955, so the FST based material, it's a bit thicker, which is one of the reasons we have the temperature control. So it has to be maintained at 60 degrees C during the print process to give you the optimized results. So for this, you can print full Z height with that material without any issues because of the way we maintain the temperature. Others can't do that.
Right, and that's what really sets this type of DLP machine apart from other technologies, I suppose.
Yeah, very much so.
The control within the actual chamber itself, and then I suppose the ability then, because of that, to produce parts in different materials with different properties that can get us into different markets, I guess.
Yeah, so again, we've mentioned previously on another video, it's an open source machine, so you can put as many different materials as you want in there. There are validated materials and preferred ones, but if you wanted to buy the OML license, fully unlocks a machine like Henkel and BASF and others do to develop materials, which then allows you to print whatever you want for whatever industry. So medical, foots, teeth, automotive, aerospace, defence, the list just sort of goes on and on.
It's amazing. It's amazing the amount of markets and applications that a machine like this can get into, really. And in terms of the setup of the machine, we're just on 3-pin plug there with a Cat5 network cable as well.
Yep, it's literally plug and play. It's one of the easiest machines to plug in and run.
Yeah, and so from a post-process point of view, we've got to take the parts off there, remove them from the head.
Yep.
IPA to clean the part first.
Yeah, so it depends on the material you're using. It's either going to be IPA or TPM or another cleaning solution, but we've got really extensive guides that tell you what to do and how to do it and the amount of time it should be done. But once you've washed the parts off, you can cure them UV. And then they're ready to go. Remove the supports and it's good to go.
And offline you were saying to me that this particular technology has got a very high green state, which means that we don't get warping within the parts. I don't know, why does that set us apart from the...
So you need less post-processing, so less issues with the thermal cure being introduced to them as well.
Right.
So you get less warping and it gets to the mechanical properties that it's supposed to be much quicker. So less, the more you sort of leave it in UV light, obviously it's going to tend to curl towards the direction of that. So reducing that means, much more stable parts.
Yeah, so I suppose during the cleaning process, it alleviates the pain of parts being broken or the geometry changing at all because it's coming off this machine in a much stronger form.
Yeah, and it also absorbs less moisture, so less of the alcohol, so you need to leave it for less time for it to evaporate off. Yeah.
We talked a little bit about some of the materials that's being utilised by this machine, but what sort of applications are you seeing predominantly being the uptake for the P3?
So electrical connectors, dental is going to be a big driving one as well, but tooling, so for metal forming tools, injection mold tooling is a good one, extrusion dies is another one. It's a huge list because there's so many materials. You get that massive diversity of applications. So, you know, good for service bureaus as well. Or if you need to do lots of connectors. So, for example, you could easily do 16, 20,000 small connectors a year on the machine. It's much more than PolyJet, much more than FDM could do. Not as much as SAF, which I've spoken about in another video, but it lends itself perfectly to those sorts of things.
Perfect. So any manufacturers who are looking to produce a volume of components which may be prohibitive with tooling, this should be perfect to have a look at
Exactly,
that.
yeah.
So you've heard it here first from Matt. If you're looking at production parts, if you're looking at prototyping on scale, high detail, high fidelity, and really key is the material properties with this technology, then get in touch with us, challenge us with one of your parts. We can get some samples printed and we can come on site and have a chat with you.